Hi, welcome to part 3 on Taylor series, and we're going to talk next about how we can use what we learned in part 2 to manipulate certain series here. Now, there's a lot of manipulation techniques. One, we can use substitution. We can multiply and divide by a constant or a variable. We can even add or subtract two series. We can differentiate or integrate. Remember, this is what we did to get cosine of x, right? To get cosine of x, we divided the sine of x, right? We took the derivative of the sine of x, right? We can also use geometric power series. We're going to talk about that at a later date. Now, so let's say we have a Maclaurin series. Now, these have to be Maclaurin. So to use these, it must be Maclaurin. Okay, it must be Maclaurin series. In other words, C must equal 0 for this to work. So I have the Maclaurin series right here. Now let's say I decide not to use a Maclaurin series and I want to write the Taylor series for this one here. Whoops, hold on here. Focus. And I want to find the Taylor series for this one. Well, one way I can do it, I can just use my integration. I can take my derivative, my function, which is sine of x squared. When I take the derivative, I'm going to get 2x sine of x squared. Well, I have to take the derivative again. Well, the problem with this, now I have product rule. And if I keep going, I have two product rules. Oops, sorry, that should be cosine of x. That's twice I've done that today. We should get, we're going to get product rule, right? So first times the derivative second plus the second times the derivative of the first. And then we got to keep going. It just gets uglier and uglier and uglier. So we have, instead, we can use these manipulation techniques. And these are going to be very nice for us today. Now, what we're being asked to do is we're asked to write a polynomial function that models sine of x squared. Well, from part 2, we know that the sine of x, remember sine of x is odd, so sine is odd. I can write sine of x as the following: x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot 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 my general term, all the way through my general term. So I go n equals 0 to infinity, and this is just x, it's alternating. So we got our negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So there's my sine of x. Well, I don't want sine of x, I want the sine of x squared. Well, that's very easy to do because one of our techniques is to substitute. I can sub in the x squared for all my x's. So everywhere there's an x, I'm writing x squared. So the sine of x squared will equal x squared minus x squared cubed over 3 factorial plus x squared to the 5th over 5 factorial minus x squared to the 7th over 7 factorial plus dot 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 all the way to my general term, negative 1 to the n. Now watch what I'm going to do here. I'm going to replace that x with x squared to the 2n plus 1 over 2n plus 1 factorial. Just replace all my x's. Even in my general term I can do that. Now I will simplify this. I don't like the way that looks, so I can write this as sine of x squared equals x squared minus, that's just x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial plus dot 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 all the way to my general term. Negative 1, let's keep that as x squared to the 2n plus 1 over 2n plus 1 factorial. And there we go. So much quicker than doing those derivative rules. Now down here we want to find a Maclaurin, so it's a Maclaurin series for this function right here. So we want to draw a polynomial function that models this, like sine of x squared. This models sine of x squared. So we're taking x times cosine of x. Well, my Taylor series I know is for cosine of x. Now we know cosine is even, so I'm using all the even powers. Like for sine here, I use all the odd ones. So I can generate cosine of x by saying it's x to the 0, which is 1, minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And there's my 4 terms, right? Plus dot 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 all the way to my general term. and this goes n equals 0 to infinity. Now we know this from earlier. This is just negative 1 to the n because it's alternating. We have to write that if it alternates. And this goes x to the 2n over 2n factorial. Now, what's going on here? I'm multiplying by x, and that's one of our techniques. We can multiply. So I can just multiply by x. Now, so if I get x cosine of x, this isn't hard to do. 1 times x is just x, minus, this just becomes x cubed over 2 factorial, plus x to the 5th over 4 factorial, minus x to the 7th over 6 factorial. There's my 4 terms, plus dot dot dot, all the way to my general term. Now, what's happening? I just multiplied by x, so negative 1 to the n, because it's still alternating. I just multiply by x. I go x times x to the 2n over 2n factorial. And you can leave it like this if you want. There's a lot of ways you can write this. So I could write this as 0 to infinity of negative 1 to the n of x to the 2n plus 1. Whoops, let me turn the light on here. Hold on. There we go. I could write that as x to the 2n plus 1 if I add them over 2n factorial. And there's our series. Now remember, what this is saying is this is only an approximation, but if I go on forever and ever and ever, these will be exactly the same. And you can try graphing those on your paper and your calculator. Just go out a lot of terms there. Alright, our last one is dealing with e to the x. Now this is kind of a neat one right here. Very easy to do. Find the Maclaurin. So again, it's Maclaurin. Say with your best Irish, Scottish accent. I'm a Maclaurin series right here. Now we're taking e to the x plus e to the x, and then we're going to divide it by 2. E to the negative x divided by 2. So the first thing you need to know is e to the x. Well, we got that already. This is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Now notice I'm not going to write my general term just yet. Okay? Let's see what happens here. If I go e to the negative x, well, what's going on here? We're just going to replace x with negative x. So everywhere there's an x, I put in a negative x. So 1, this becomes minus x. Because of the even power, that becomes plus x squared over 2 factorial. Odd power becomes negative x cubed over 3 factorial plus dot dot dot. Now, I got my 2. Now I'm going to add them together. So I go e to the x plus e to the negative x. Well, if I do this, look at this, I can add those together, I get 2, but what happens to the x's? Those cancel. Nice. Over here I can add them together, so I get plus 2x squared over 2 factorial. Don't try simplifying yet, don't be a hero. X cubes cancel. Matter of fact, all the odd powers are going to cancel. Okay, but warning, remember, we wanted 4 terms. We wanted 4 non-zero terms. I only have 2. So I continue the pattern. And you're probably right, it's all the evens. So my next one will be plus 2x to the 4th over 4 factorial, and one more to get my fourth one, 2x to the 6th over 6 factorial plus dot dot dot. Now notice I haven't done my general term yet because this is a lot harder to do. Over here it's pretty easy to kind of figure out. Just multiply by x, right? Here, replace with x squared. But down here there's a lot going on, so I'm going to wait to do my general term until the very end. And my last thing I'm going to do is divide by 2. So if I divide here by 2, I get 1 plus, divide here by 2, x squared over 2 factorial, x to the 4th over 4 factorial, plus x to the 6th over 6 factorial plus dot dot dot. And now at the end, I'll write my general term. N equals 0 to infinity. And don't forget the plus dot dot dot. You need this. You need that plus dot dot dot. So what's the pattern? It's just all the even powers. This is x to the 2n over, looks like, 2n factorial. And there's my rule. 2n, right? Because this is, remember, to try generating check it. Plug in 0. X to the 0 over 0 factorial, which is 1. Plug in 1, right? And is 0. N is 1. The number of term. Remember, this is my term number here this time, right? Not my derivative, my term number. So plug in 1, x squared over 2 factorial, and it works. Alright, so there we have it. So you have some practice on these, of course, so work on them, and we'll be in class. You can ask some questions. Bye-bye.